The function notation. Suppose we have a function, call it f, and make it simple. F of x equals 3x plus 5. So this is what's called a linear function, and the idea is that for any number x, you multiply that by 3 and you add 5 to it. So for example, f of 10, well, 3 times 10 is 30, plus 5 is 35. The letter x here is just a generic sort of placeholder to stand for the idea of anything you want to put in there. And if we were to say x is some other thing, like 2 plus 7, well, of course that's the same thing as 9, but you could write f of 2 plus 7. And all that means is you take 3 times the input, which in this case is 2 plus 7, and you add 5. And it's up to you to decide whether you want to use the distributive property to go 3 times 2 plus 3 times 7 plus 5, or whether you want to add the 2 and the 7 together and then multiply by 3. Laws of mathematics say you get the same result regardless of how you do that. Now, the only reason I bring that up is because, well, suppose we had f of x plus 7. Well, our function was 3 times whatever the input is. In this case is x plus 7. And then to that, you add 5. X plus 7, we don't have any choice of adding those two things together. X plus 7 is x plus 7. But the distributive property says that 3 times x plus 7 is 3x plus what, 21? And then if you add 5 to that, we've got 3x plus 26. Let's look at a slightly more complicated function. G of x, say it's the function x squared plus 6x. The basic idea again is that g is just the name of the function, the rule that says square the thing and then add 6 times the thing. If the thing is a number, say it's 4, we're looking at 4 squared plus 6 times 4. What's that? 16 plus 24. I think that's right. Shouldn't have to grab a calculator for that. And what is that? 40. The x is not really important to the whole process, so sometimes somebody will go in and come in and say, oh, well, what's g of a, let's say. And there's really no difference between calling the input x and calling the input a. And all that means is that the input, which in this case is a, is going to be squared, and then you're going to add 6 times that input. Not terribly exciting, but sometimes confusing where you just change from one letter to another. Now, as before, you could have a sum of things being the input. So suppose the input is a plus 4. Well, again, the g function takes whatever the input is, in this case a plus 4, and squares it. The correct way to represent that mathematically is to put the a plus 4 in parentheses and then the squaring outside of that. And then this was plus 6 times the input. And so plus 6 times. And then again, since the input is all of a plus 4, we have to put all of a plus 4 in parentheses. The rest of it's basic algebra that you're hopefully familiar with. If you square out a plus 4, that's a plus 4 times a plus 4, and that all works out to be a squared plus twice 4a, so that would be 8a, and the square of 4, which is 16. So remember, the square of a plus 4 is not a squared plus 16, it's a squared plus 8a plus 16. And then we have, using the distributive property again, 6a plus 6 times 4, 24, and then you just combine like terms and we have it. So a squared plus, what is that, 14a's altogether? 14a plus 40 again, yeah. You can check to see if this works by noting that suppose, for example, a is 1, in which case a plus 4 is 5. And what we can see here is that g of 5 would be 5 squared plus 30, 6 times 5, which is 55 altogether. And on the other hand, if you look at this expression here, we would have a squared. Now remember, a is 1 in this case. So 1 squared is 1 plus 14 times a. 14 times 1, of course, is 14 plus 40. And 40 plus 15 is, in fact, 55, as we saw when we looked at a plus 4, which is 5. And so these two things agree. Anyway, that's just a short intro into function notation. And we'll leave it at that for now.